Hi guys, my name is Joshua and I will teach you on how to solve the theorem 1 and 2 of the limits of the function. So this theorem 1 states that the limit of c is equal to c as x approaches a. So here is our example, and our example is limit of 8 as x approaches 1. So what we're going to do is we're going to multiply the 8 and 1. 8 multiplied by 1 is equal to 8. So our final answer will be 8. So here's our theorem 2. The theorem 2 states that the limit of x as x approaches a is equal to a. So here's our example. The limit of x as x approaches 69. So what we're going to do is we're going to substitute the value of x to 69. So it will be 69. Now that I've taught you the theorem 1 and 2, let's now proceed to the next one.
Hi guys, my name is Joshua and I will teach you on how to solve the theorem 3 and 4, the limits of the function. So let us start.
So basically this theorem states that the limit of x squared is equals to a squared as x approaches a. So here's our example. The limit of x squared is equal to a squared as x approaches 3. So what we're going to do is we're going to substitute the a and we're going to make it 3. So it will be 3 squared. 3 times 3 is equals to 9. So our final answer is 9. So I am now going to teach you the theorem 4. So the theorem 4 states that the limit of f of x plus g of x as x approaches a. So here's our example. Limit of 6x plus 2x as x approaches 2. So what we're going to do is we're going to substitute it again. So it will be 6 times 2 plus 2 times 2. 6 times 2 is equal to 12 and 2 times 2 is equal to 4. And 12 times 4 is equal to 16.
Now that I have taught you the theorem 3 and 4 of the limits of the function, let's now proceed to the next one.
What's up guys, so today we're gonna teach you the theorems on limits. So the theorems that I'm gonna teach you more specifically the limit 5 and 7. So without further ado, let's get into this tutorial. To start off, the theorem states that limit of f of x times the limit of g of x is equal to limit of f of x times the limit of g of x. It's basically f times 2. If you say this, you'll be multiplying the f and g and you're just gonna substitute the x. Example, let's say that limit of 4x squared as x approaches 2. Now, we'll just be substituting. So 4 2 squared. So 2 times 2 or 2 squared is 4. 4 times 4 is 16. So it's basically that simple. Now let's have another example. Limit of 5x squared multiplied by negative 2x. So as x approaches, now as we did here, we'll just be substituting. So 5 2 squared, then negative 2x, replace the x with 2, so negative 2 times 2. So let's evaluate this. So 2 squared is 4, then 2 times negative 2 is negative 4. 5 times 4 is 20, 20 times negative 4 is 80. That's the final. Now, so here is the 7th theorem in limits. So this theorem states that limit of 1 over x r is equal to 0. Now this r is actually just an exponent. It's any exponent. It can be 1, 2, 3, it can be any. So xr is just any exponent. Any variable with exponent as x. What does that mean? I have here an example. So 5 over x squared is equal to 0. Now why is that? As this theorem states, 1 over x is equal to 0. And here we got 5 over x squared, xr. squared. It's that exponent. Here is a natural number. It is equal to 0. Okay, that's cool, but where are we gonna use this when a limit is approaching infinity? Limit of x squared of minus 9x all over x plus 5 as x approaches infinity. Now, how does that work? It's not like we can replace x with infinity. So, yeah, we can. So that's why we're gonna use this theorem. So when it comes to this, we're gonna multiply all of these variables and numbers with this. So multiplying all of these with 1 over, find the highest exponent in this x squared. We're gonna times all of this, all of 1 over x squared to all of those variables and numbers. So you can cancel So the final answer is 1.83. Now that we've teach you all of the theorems on limits, we're now gonna give it to Howard to apply it to the real life. So I'm gonna give it to him and see you. Bye.
Hey everyone, in today's video, I want to talk about the power of setting limits and how it can help you achieve your goals. Whether you're trying to lose weight, save money, or improve your focus, I'm going to show you examples on how to do it. Let's start.
Let's start with screen time. We all know how easy it is to get lost in our phones and spend hours scrolling through social media. Instead, I set a limit of no more than 2 hours per day on my phone. I use an app to track my usage and stay within my limit. This has helped me tremendously to stay more present and mindful, and avoid getting distracted by online content.
Finally, let's talk about water consumption. Drinking enough water is crucial for health and well-being. To stay hydrated throughout the day. That's why I set a goal of drinking at least 8 cups of water per day and carry a reusable water bottle with me wherever I go. So there you have it. These are just a few examples of how setting a limits can help you achieve your goals and improve your daily life. Remember, the key is to make your limits realistic, measurable, and sustainable. Thanks for watching, and I'll see you in the next video.